All right, let's attempt the very last question, number 5. It reads, find all of the radian measures which satisfy sine theta equals square root 3 over 2. Now that number looks very familiar to us, and that's because it's going to come from us using the special right triangles. And so there are 2 steps to this question, and the first step will refer to the video also assigned for today that goes over the unit circle shortcuts. And so I'd like to just summarize it very quickly. When we deal with special angles and radians, what that means is we're going to be referring to the special right triangles. And so in our unit circle, there are only so many. The 45, 45, 90 triangle, which will also be repeated here, as well as here, and here. And the 30, 60, 90 triangle. 30, 60, 90, 30, 60, 90, 30, 60, 90, and 60, 30, 90, 60, 30, 90, 60, 30, 90, which are pretty much the same thing. And she went over a simple way to memorize this. Now I'm going to present a slight variation to it, but bear with me here. I'm going to be looking at the x-coordinates of these dots because they get repeated for all of the other dots of the unit circle. So if I look at the simplest, I know that this is going to be 0, and I know that this is going to be 1. But instead of writing in 1, what I'm going to be doing is measuring the x-coordinate of these dots in the order that they're presented. So this is the first x-coordinate, then the second, and then the third, and then the fourth. This makes sense because this is shorter than this length, which in turn is shorter than this length, which is in turn shorter than this. So it goes in smallest to greatest order. All right. From here, what I'm going to then do is square root the number and divide it by 2. What that does is it then simplifies into the values we're more familiar with, and that's 0. We know that this coordinate was in fact 0, 1, and this simplifies into 1 over 2. This simplifies into square root 2 over 2. This simplifies into square root 3 over 2. And this simplifies into 1, which matches what we learned before. We're going to do the same exact steps for the y as well, but because the y starts at 0 here, we're going to go up 1, 2, 3, and 4. Because as you can see here, this value is smaller than this value, which is in turn smaller than this value, which is in turn smaller than the topmost value. And here again, square root, divide by 2, 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 square root, divide by 2. And so we get the simplified value. 1, square root 3 over 2, square root 2 over 2, 1 over 2, and 0. So as you can see, these values, which we had to work so hard for, come now quite easily for us as long as we memorize this method of drawing out the unit circle. So why do I mention this? Because the first step is to find out where in our unit circle we have the following y value. Well, we have the following y value here, which means it's at this point here. And this coordinate will be the exact same y coordinate as this, because here we have 1 over 2 comma square root 3 over 2. The only difference is that the x is negative since it's on the negative x coordinate. Negative x-axis, sorry. So this gets repeated. And you might notice that those same values get repeated here, where this is also 1 over 2 square root 3 over 2, 1 over 2 square root 3 over 2, where here they're both negative and here the y is negative. going back to the question, they asked when is the sine of theta positive square root 3 over 2. So that means only these two values. And so my answer is this radian measure here, which is 60 degrees, or pi over 3, or this measure here, which is 120 degrees, or 2 pi over 3. And so my answer should be pi over 3, or 2 pi over 3. But here comes the second step. If we redraw one of those radian measures, yes, the y-coordinate of this radian measure is going to give us square root 3 over 2 like we wanted. However, if we went forward a full circle before we reached here, so instead of pi over 3, it's now pi over 3 plus 2 pi, we would still end up with the same value. So it's not correct to just say that this will give me square root 3 over 2. It's in fact going to include every number that ends on this terminal sign. So whether I go forward a full circle before going that pi over 3, or backwards full circle, before going to pi over 3, it doesn't matter. We still end up at square root 3 over 2. So your full answer should include every value where we add a full circle, and it must be a whole full circle. You can't go halfway across a circle and then stop and expect to end at the same dot. So we are going to go full circles and guarantee that by making sure that k is an integer. Remember, this is the notation for Zahlen, or integer. If you don't like writing this, you can just say where k is an integer. And so I think you know where I'm going with the second answer here. We should also include this phrasing. And so this answer is half correct, but the full answer should include every possible radian measure, which will come out to an infinite number, but that is your full answer. All right, good luck with everything else, and please email me if you have any questions. Good luck.